In this video I'm going to give a very quick overview of this issue of modeling nonlinear relationships using linear regression models. We're looking at data that plots miles per gallon that was realized on a certain car versus the tire pressure that was used on that car. And what we're seeing here, the data are the blue diamonds, we're seeing there's a relationship, but it appears to be a nonlinear relationship. The relationship appears to curve. Now we can fit a straight line model to this data, and I have done so, and the red line is showing the resulting plot. Later in the unit we'll see the statistical output showing that this is not showing up as a significant slope, but now just visually what we see is I'm trying to fit a straight line where my data is actually showing something like a curve. If we looked at the residuals plot for this relationship, for this model, we would see that we have a lot of negative residuals over on the left end of this line where the data falls below the line. We have a lot of negative residuals for the high values of tire pressure, and we have a lot of positive residuals, meaning the data lies above the line in the middle. This is counter to our typical expectation, or what we're usually looking for. What we want to see is the data randomly scattered both above and below the line along the length of the entire line. In other words, we don't want to see, here's a plot of those residuals, and we don't want to see this pattern in the residuals. We want to see the residuals scattered randomly above and below zero across the entire range of this plot, not have all the positive ones in the middle and all the negative ones at either end, as we're seeing here. So what we're going to learn to do is learn how to fit a nonlinear relationship. The basic method is we fit a model where we add an x squared variable to the model. So instead of my function being y equals beta 0 plus beta 1x with just an intercept and a slope, I have y equals beta 0 plus beta 1x plus beta 2x squared. And if you remember from your algebra, that gives me a function that we call a parabola, or in other words, the slope can change. It's going to be a curve rather than a straight line. And when we fit the relationship, we see that now I have my residuals, my data is scattered randomly above and below the entire curve, or in other words, the residuals for this model are scattered randomly above and below zero across the entire length of the plot. So the whole point of this is being able to fit nonlinear rather than straight line. In this case, we need a curving or nonlinear relationship to appropriately model the data.